Good morning, class. Today we're going to learn how to perform linear regression analysis on our calculators. It's a very simple idea. Basically involves finding the line of best fit through a set of data, through a cloud of data points. So the first step is to turn our calculator on by pressing the on button. Next, we're going to go to the list editor, which can be found under Stat, and then select number 1, Edit. Many of you will have a blank series of lists, L1, L2, L3, etc. If your lists are not blank, please scroll up to the name of the list, L1 in this case, and press Clear, and then press Enter. That will clear all the contents of your list. So be careful, don't do that by accident on the wrong list. I'm going to clear both lists and get ready to enter my data. So here I'm just going to use a sample data set that's not very exciting, only 4 entries. So my data entries are 0, 2, 3, and 5. And those are my inputs in my data set. And then for my outputs, I happen to have 50, 70, 100, and 90. Again, I'm just making these up. They're not particularly important. I just wanted to give you a small sample. So now we've entered our data in our calculator. It knows it. It'll save it automatically. We don't have to do anything to do that. Okay. Next thing we're going to do is graph our data. Okay. And to do this, we're going to go to Second, Y equals, which gives us our stat plot editor. And then we're going to press Enter on plot 1. When we go to plot 1, we're going to turn it on first by pressing Enter on. Then we're going to go to data type, and we're going to go to this first one, which is scatter plot. Now we're going to make sure that our X list, our input list, is the input list from our lists, which is L1, and our output list is L2. And we're going to have a mark here. It's possible that your screen might appear different at this point, but it shouldn't. It should be all the same. Now the next step is to choose the proper window. Right? We need to pick a window that will fit all of our data. So the standard window, which is -10 to 10 on X and Y, is not going to fit because we have data that's bigger than this. We have 50 and 70 and so forth. So we need to go to the window here, and then we're going to set this. You'll notice that our X's, we have nothing less than 0, so we'll use 0 as our minimum. Then we can use 10 as our maximum, or 5, or whatever. Right? And then we're going to go to X scale. We'll leave that as 1. That just tells us the tick marks. So in other words, how many tick marks there are, how big the value of each one is. So 1 is fine. Go 1, 2, 3, 4, etc. For Y-min, we have different. We need to change this. Our smallest is 50, right? But we're going to set it at 0 so we can see all the possibilities here. We can see the whole first quadrant. And our biggest is 100. So I'm actually going to go to 110. So a little bit beyond. Now you'll notice if I put 1 for my X scale, right, that's going to give me a lot of tick marks, 110 of them. That's too many. So I'm going to set this to be 10. Right, so that every 10 units I have a tick mark. Always leave XRes as 1. Right, you should never have to change that. Now we're going to go ahead and go to Graph. And you can see that we have the points. Right, here we have 0 at 50. Right here we have 270. 3 100, and 5 90. Now if you want to see this point here a little better, we can just adjust our window so that we go slightly into the negatives for our X's. Just go to -10 or so. Oops, sorry, -1 will be fine. And now we get a better sense of that plot. So looking at this data set, it's not particularly linear, but we can still use linear regression to fit a line to this data, which would go something like this probably. Right, something like this along these lines. So in order to do this regression, which we'll let our calculator pick the line for us, right, the first thing we need to do is go to the catalog, Second, 0. We're now going to hit, we're going to go down to Diagnostic On, and instead of scrolling down all the way, we're going to hit Matrix here, because you'll notice there's a little D over Matrix, and up here in the corner is an A, that stands for alpha. So if we hit Matrix, it'll bring us to the D's automatically. Then we can scroll down from there. It's a little shorter trip. Diagnostic On, press Enter, and press Enter again. You won't notice any difference there, but if you don't have your diagnostic on, this won't work properly. Okay, so now we're going to go to our regression tools. Okay, so to use our statistical analysis tools, we go to Stat, and then we go over to Calculate. Okay, we're going to choose the correct type of analysis here. We're going to go to linear regression, A plus BX, or sorry, AX plus B, which you'll notice is linear. It's MX plus B with A instead of M. All right, and we're going to press Enter. When we do this, right, we could just press this and something would happen, but it might not be what we want to have happen. So if your calculator appears like this, here's the procedure, right? We're going to go second, 1, which gives us list 1, which remember, that's where our x's are. And we want our y's, and that's in list 2. The last one's a little tricky. We want to automatically store the equation for this line, right, in our graph editor, our equation editor. Right? So we're going to go to vars for variables, and yvars, and then function, and then y1. So again, what we're doing here is we're taking list 1 and list 2, our x's and our y's. We're performing linear regression. We're finding a line through those points, and then we're storing the equation automatically. So it'll generate the line automatically. Okay, and then you press Enter. If your calculator doesn't look like this, right, there's a slightly different technique. But if it does, we get this screen here. We get A, our slope, B, our y-intercept, and then R squared and R I'll talk about in just a few minutes. Okay? If your calculator looks different, let me show you how to work with that. Okay, so if you go to the stat editor, and calc and number 4. If it looks like this, it's a similar process to what we just did. We have list 1 and list 2 in there already, right? And then we can ignore frequency lists for this type of graph. We want to do store regeq. That's the same idea that we did last time, right? Storing the regression equation. So we go to vars, yvars, function, y1, and then we press calculate. And you'll notice we get exactly what we got the other way, so it works perfectly. Okay, so either way, whatever your calculator looks like, you should be able to do this. Let's talk briefly about these R squared and R values. As we said, A is the slope, B is the y-intercept. R squared and R are measures of how well the line fits the data. If we take a look at this line, right, it's automatically graphed. It goes through or near many of the points, but not particularly well. It doesn't fit the data very well. This data is not that linear. The example you're going to do in a few minutes, right, is quite linear, and you'll see a much bigger value, right, of R squared and R. The closer R squared and R are, right, to 1, the better the fit, right? If this was 0.99, that would mean it's almost a perfect fit. If it's exactly 1.0, that means the line goes through every data point perfectly. If it's 0, that means that there's no linear relationship here whatsoever. It's basically a big random cloud of data. There's no linear relationship. That doesn't mean there's not another type of relationship, but it just means there's no linear relationship. Okay, so again, we have our equation here, slope, intercept, and then these tell us how well that equation fits our data. All right, so now you're going to start working on your packet, and that's due for tomorrow if you don't finish it in class. All right, enjoy. You can always Facebook me if you have any questions.